Welcome to Introduction to Geographic Information Systems. This, and the other learning resources in this course have been made possible by funding from the European Commission's Erasmus Plus program. All geographical data are an abstraction of reality. A fundamental abstraction is scale because the world is a big place. One of the challenges behind mapping the world, and its resident features, patterns, and processes, is reducing it to a manageable size. What exactly is meant by manageable is dependent on your personal needs for your work. Map scale refers to the factor of reduction of the world so it fits on a map. Map scale can be represented by text, a graphic, or some combination of the two. For example, it is common to see 1 inch represents 20 miles, or something similar written on a map to give users an idea of the scale of the map. It is important to keep both your map distance and true ground distance given in the same units. This makes representation neutral. In other words, any unit of measure can be used to interpret the map scale. Consider a map with a scale of 1 to 10,000. This means that 1 unit on the map represents 10,000 units on the ground. Such units could be inches, centimeters, or even pencil lengths. It really does not matter. This ratio is called the representative fraction. The numerator, which is always set to 1, denotes map distance and the denominator denotes ground or real-world distance. Map scale can also be portrayed graphically with what is called a scale bar. Scale bars are usually used on reference maps and allow map users to approximate distances between locations and features on a map, as well as to get an overall idea of the scale of the map. Large scale means that the ratio is large, so typically it means there is much detail, as in a 1 to 1000 paper map. Small scale, in contrast, means a small ratio, hence less detail, as in a 1 to 2,500,000 paper map. This has implications for data. Large scale typically means that there will be more data, and this might have implications for storage and computing power. It also has practical implications for presenting. All maps possess a scale, whether it is formally expressed or not. Some say that online maps and GIS are scaleless because we can zoom in and out at will. It is probably more accurate to say that GIS and related mapping technology are multiscalar. However, what if you need to share the map with someone else as a PDF or print it out? A 1 to 5 map would be incredibly detailed and maybe not that useful. A 1 meter map would only represent 5 square meters, which means you would probably have to print out a couple of maps just to represent a room. When choosing scale, you need to focus on providing the right level of detail. If you are focusing on a city, then you don't need a map that covers a whole country. Similarly, you don't want one that only covers a street. You need to focus on a scale that conveys your message to any potential reader. Choosing the scale also has an implication for the data you want to use, as it affects data resolution. Data resolution is the smallest difference between adjacent positions that can be recorded. Since a paper map is always the same size, its data resolution is tied to its scale. Resolution also limits the minimum size of feature that can be stored. Generally, a line cannot be drawn much narrower than about half a millimeter. Therefore, on a 1 to 20,000 scale paper map, the minimum distance which can be represented is about 10 meters. On a 1 to 250,000 scale paper map, the resolution is 125 meters. But what if your road is only 50 meters across? Well, you do not need to make your map accurate. You can make representative maps that show other factors. However, if you want people to be able to use your map for accurate measurements, then you need to consider what you want to show and how practical it will be to do that. If you want a country-wide map, then you don't need data down to a meter accuracy for buildings, as they won't show up on your map. That is large-scale data on a small-scale map, which wastes resources. Make sure when you are searching for or collecting your data, that it is appropriate for your scale.